In this video, we will let the clients use the tools to interact with resource nodes and eventually drop the resources that we can pick up. And we are going to have some health value so that we need to hit the resource node a couple of times so that it breaks. For the tool interaction with a resource node, we are going to use RPCs, and for the health value storage, we are going to use network variables. In a multiplayer game, the visual feedback as well as the audio feedback is usually played by each client separately, since we just need to synchronize the event that we are interacting with the object, but the visual feedback and audio feedback does not have any effect on the gameplay, so it can be played locally. We would do this to limit the amount of data we synchronize over the network to minimize latency and any delays that might happen in a multiplayer game. I just want to point out that we have talked about the camera, the main camera resetting, and if we connect again, it will follow the player. But you will notice that if I pick up this tool and move and disconnect, the tool will be dropped here. If I disconnect the host and start again the host, you will see that the tool remains here. To deal with it, we would probably have a separate scene, a menu scene where we connect with each other and then reload the scene to reset the positions of each object that was already present in the scene. But back to the topic of this video. Before we can start working on the logic to interact with the resource nodes, so the tree and the stone, we have to create two scripts in our _scripts folder. So let's right click, create a new mono behavior. Let's create one called interact animation. And let's confirm. And we need another one, right click, create a new mono behavior, items, audio. And let's confirm. This is because I forgot to include two feedback scripts that will be available on our GitHub repository in video 6 branch. There will be a link at the top of the description, and just enter the interact animation script here and copy the code here to your own script. So here it is. You may need to import some using statements, but besides that it all should work. And we need the items audio script to be copied as well. Here is my script. There is nothing specific in those scripts when it comes to multiplayer, but feel free to take a look at how they work, and when you're ready, just save those scripts and let's go back to Unity. Now we are ready to create our resource node script, so let's create one here. And let's open this script up. This script will need to inherit from network behavior and also implement the iInteractable interface. That's because our interaction detector script searches for iInteractable objects, so if we want to interact with our resource nodes, we need to implement this interface. Let's right click on it and quick actions implement this interface, which will require us to have the toggle selection method. Next, we are going to add quite a few fields at the top of this script. First one will be serialized field private selection outline _selection outline, since we want to add an outline around this object when we have selected it so that we can start interacting with it. And we can actually go down to the toggle selection method and just check if _selection outline is not null. We are going to just toggle the _selection outline .toggle outline, passing the isSelected bool flag that we pass here as a parameter. The next field will be serialized field private component controller _component controller. This is because the trees and rocks are already in our scene, so if we try to despawn them, they will not be removed, and if someone is joining our session late, the resource nodes will be still visible to them. So we are going to use the component controller to hide those objects, and it will automatically synchronize the newest state of those objects even with the late joining clients. To specify which object can interact with this resource node, we are going to have a serialized field private list object type m_tool type required, so that we can specify which tool can be used to harvest this resource. Now we are going to also define what will be produced, so serialize field private object type m_produced object type. I'm just assuming that we produce one resource type from a single resource node. And we define serialize field private int m_amount to spawn, and this will be 3 by default, just to show you how to spawn 3 different objects. Now, next we are going to have a serialize field private interact animation m_interact animation to visualize that we are interacting with the object, because next we are going to add health value to it. And we are going to use for the same purpose serialize field private items audio m_items audio to play some sound effect when we interact with the node. Now, to store the health value, I have mentioned that we are going to need a private network variable, and we are going to pass int m_health equals new, and we are going to pass 3 as the default health value. Usually, it's a good idea to override the onNetwork spawn method, and here check if is server, and if this is a server, assign the m_health.value equals 3, so the start value of the health for this object, because we want the value to always be reset. That is the most sure way to assign this value correctly. Now, beside those 2 methods, we are going to create a public void harvest, and we are going to pass here object type, and this will be tool type. First, what we want to do is check if is server with an exclamation mark. If this is the case, we are going to return. We add this because the server has the authority over the gameplay in our game. In the previous videos, I might have mentioned that this is because the server owns the game object, but the accurate explanation is that the server has the authority over the gameplay, and it has the final say over who won and who lost, because it stores the most up-to-date state of the game, and it can only make decisions based on it. Because our harvest method takes the tool type, so the object that we are using to interact with this node, we are going to check if the m_tool type required contains this tool type. If this is a valid tool, we are going to first call m_health.value, we are going to reduce it by 1, and next we are going to create a new method play audio client RPC. I'm just adding this client and server to the names of the RPCs for you to know who is calling them, but basically let's generate this method. For now, let's keep implementing this method, and we are going to add if m_health.value, if this is greater than 0. In this case, we are going to call another RPC to play the shake animation. So play animation client RPC. Again, let's generate it. So we play our animation to let the client know that the resource node was affected, and else, so if the health drops to 0 or lower, we are going to call m_component_controller set enabled false, so that we destroy the resource node, or actually hide it. And next we are going to loop for I equals 0, I less than the m_amount to spawn I++, so we are going to spawn the game objects, so the resources. For it to work, we do not have yet the script to spawn those objects, but let's calculate the position. So vector 3 position equals transform dot position. So we are going to just get the position of this resource node, position.y equals 0, this is my ground level, and to add some randomness to this position, we are going to call vector2 offset equals unity engine.random.inside unit circle. Now we can assign position.x plus equals offset.x and position.z plus equals offset.y. We do not yet have the logic to spawn our resource, so let's debug.log and we are going to just type spawning. Probably this will be something that we implement in the next video. And this is our harvest logic. Now let's go down to this play animation and play audio RPCs. To define an RPC, we need to add the attribute, and part of it is sent to. Previously we have used sent to server. To my best knowledge, what we want to have is sent to client and host to send it to all the clients who has joined our game. So above both of those, we are going to add the square brackets RPC send to the client and host, and let's copy it and add it above the play audio client RPC as well. For the play animation method, we are going to just check if our m_interact animation is not null. Here we are going to just call on it m_interact animation.shake, and let's do similar thing in the play audio client RPC. So if m_audio item is not null, it would be good to check if the m_health.value is greater than 0, because this means that the object still exists in case we destroy it. If it still exists, we can call m_item audio.play sound, assuming that the audio source is on the same object. Else, if the value of health drops below or equal to 0 and we destroy the object, we can call m_item items audio.play sound separate, which basically uses audio source.play clip at point without using the audio source assigned to it, so that the audio still plays even if we destroy the game object. Okay, that is it for our script. When you're ready, save the script. Let's go back to Unity. Now we need to apply this script to our tree and rock objects. So let's go to the network prefabs folder. Let's find the tree object. It already has the capsule collider and selection outline script. We're going to add network object because we need to add it to every object that performs a role in a multiplayer simulation, but we can uncheck synchronize transform because we do not move those objects. Next, we are going to add component controller, and here we want to add two references. First one will be to the collider and the second to the mesh renderer. We want to disable both when the tree or the stone is destroyed. We will also add here items audio script, which will add automatically the audio source. If you have added required component type of audio source at the top above the name of the class, you can add it later or right now. And if we go back to Unity, it should add the audio source. We do not have to prepare it, but we want to add to the tree the axe sound. And last thing is the animation script, so interact animation, and we need to assign the transform of this object. When we have all that, let's add a resource node script, and we need to assign the outline component. Here it is, selection outline, the component controller. The tool required, we are going to add one position. This will be an axe. For the stone, it will be a pickaxe. The produced object type, this will be wood, and we need to assign the interact animation script and the audio, the items audio script. Okay, we need to repeat the same setup for the stone. Feel free to pause and add those components. The biggest differences will be in the resource node, since we need to have a pickaxe and produce stone, and in the items audio it will use pickaxe sound, but the rest will be the same. We enable and disable the mesh renderer and the capsule collider, and the network object will have the synchronize transform disabled. Now all the trees and rocks in our scene will have all of those components, but we are not done yet. We need to still go to our scripts folder and open our player controller to trigger all this logic. Like with the easy interacting, we need to add another bool flag m_is_chopping. Next, in the on enable, we need to assign to our m_player input.on interact pressed, and we are going to add here a handle action pressed. And let's copy this because we need to find onDisable and unassign this method before we can right click on it and generate it. Let's go to this new method and we are going to first check if isOwner flag, and if this is false, return, because only the owner can trigger this action. Now next, because we have two states, the interacting and chopping, if the m_is_chopping or m_is interacting, we are going to simply return, because we cannot really perform an action when we are already doing something else. Now we need to trigger the chop animation, so let's type if m_held object type dot value is object type dot ax or object type dot pickaxe, and only in this case we are going to set m_is chopping equals true, and we are going to trigger the animation m_animator dot set trigger, and we are going to pass chop. Since this will trigger the chop animation, we need to find the onNetworkSpawn method, because here we have assigned a custom method to the m_animation events dot on animation done now on interact plus equals handle chop action. Again, we can copy this and find the onNetworkDSpawn method, and we should always unassign our custom event handlers from those. I made a mistake here. We wanted to have the onChop minus equals handle chop action, and we need to find the NetworkSpawn method, and here we also wanted to have the animation events onChop plus equals handle chop action. And now we can find the name of the method, and let's quick action and generate this method. Similarly, with the interact animation, this will be triggered at a specific point of the animation, and inside this method we are going to check if m_held object type dot value. We are going to again check is object ax or is object type pickaxe, and the GitHub Copilot already gave me the hint that we want to check if m_interaction detector dot closest interactable is resource node, but we can't really use it like this. We need to use an RPC, so let's type request resource node interaction server RPC, and we are going to pass m_interaction detector dot closest interactable, and we need to pass the ID of the network object, so .networkObject.networkObject ID. We can right click and generate this method so that we do not have to type it. And since this is an RPC, we are going to add an attribute RPC sent to server. Here we will have similar logic as with our pickup request. So we need to check if !network manager dot spawn manager dot spawn objects try get value, and we are going to pass the network object ID that we have received here, and we are going to output network object target. Now if we have it, we are going to follow up with if !target.getComponentOut resource node. If this is not a resource node, we will return. And finally, if it is a resource node, we are going to call harvest and pass the m_held object type dot value to let the resource node know what we are using to interact with it. Because we are using m is chopping and m is interacting or m is picking up bool flags to store our state of the player, we need to find our, I believe at the bottom, update method. So we have forgot to check if we are interacting or chopping, because in this case we do not want to move. So let's add just below this vector2 if m_is chopping or m_is interacting. We are going to set the movement input to vector2.0 so that we do not move when we perform those actions. Next, let's search for our handle pickup pressed method, and here we have checked m_is interacting or underscore is chopping. So this will again block our pickup pressed interaction. We need to also find handle action done. I think we had something like this. A handle animation done. Here we need to reset m underscore is chopping, and this will be false. And I think finally we are done with changes in the script. Feel free to browse the GitHub repository and verify if we have copied everything correctly. Let's save this script and let's try pressing play. If we start the host and the client, we should be able to pick up a, for example, 𝗏𝗃𝗃𝗃, and if we try interacting with an incompatible node, so with the stone, nothing happens. But if we interact with the tree, you can see that the animation is played, and if we disable the sound here, the sound should be played on the other object. If you take a look at the console, you should see the spawning called 3 times because we spawned 3 objects. If the player 2 disconnects and starts client again, you can see that the tree is no more, and we can pick up the pickaxe tool and try to do the same with the stone. And let me switch to the player 0, pick up the pickaxe and try interacting, and as you can see, the stone disappears for both clients. See you in the next video.